Hello my dear students, welcome to IMS Gate Academy smart revision session on digital circuit subject. So this subject is common for 4 branches: EC, electrical, instrumentation and computer science. So today we are having 2 sessions, right? So currently 1:32 3 and then we are having one more session today 3:32 5. So in these 2 sessions together I am going to do the revision of the entire digital circuit subject. So this is one of the most important and scoring subject for all the 4 branches: EC, electrical, instrumentation, computer science. So all of you kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from these 2 sessions. Okay. So before going to start the session, I am going to give 2 updates. So all of you just listen. Okay. After that we are going to start today's session. Okay. So the first important update, so at our IMS Gate Academy, we are having the live online program for 2025 and 2026. Whoever targeting for Gate 25 or 26, so we are at our IMS Gate Academy, we are having the live online program. So whoever interested, whoever targeting for Gate 25 and 26, so all of you can just book the free counseling session regarding this particular link. It is available in the description of this particular video. So if you are enrolling for this particular program, what are the benefits or what are the features you are having regarding this particular program that I am going to discuss now. So here all the classes will be in the live online. Okay. So together you are having 800 plus hours of live classes. Okay. And in addition to that, we are going to provide theory book, exercise book, and one of the most important among these various books, the previous year GATE question bank. So in this GATE question bank, we are having 30 plus years. That means around 33 years previous year questions. Along with that, detailed solutions we are having. This is one of the unique book. So if you are going through this particular book, you will get great learning from our GATE question bank. Yeah, very good afternoon one and all. Okay, in addition to that, we are providing 12 My Plan sessions. So that every month on an average, whoever students enrolled for live online program, they can book one My Plan session slot with the corresponding mentor and they can get the proper study plan and proper guidance from the mentor. And in addition to that, here we are providing live online classes and we have provided theory book, exercise book and GATE question bank along with detailed solution. And not only that, here we are providing 130 plus online tests. Here you will be having, for every chapter, one test will be there, that is called chapter test. And then for every subject level, there will be 3 tests will be there, like basic test and then advanced test. After that, multi-subject test. Okay. After that, we are having all the mock tests as well. So whoever students, after getting confident from theory book, exercise book, okay, after attending our classes, they can start attempting these tests so that they can check their confidence and knowledge regarding that particular chapter or subject, etc. Okay. So all these benefits you are going to get if you are enrolling for GATE 25-26 at our IMS Gate Academy. So for your GATE preparation, whatever required here at our IMS Gate Academy, we are providing each and everything. Okay. So this is one important update. So whoever targeting for 25-26, so all of you can share this valuable information with your friends and juniors. Okay. And one more update here regarding our Telegram group. Okay, I hope some of you already joined regarding our Telegram channel. Okay, whoever not yet joined, okay, regarding this particular link also provided in the description. So all of you kindly join. It is free for everyone. Okay, right. So what are the benefits that you are going to get if you join our Telegram channel? Say for example, currently live class is going on, right, in our YouTube channel. Okay, so like that, whatever the upcoming events are there regarding live online classes in our YouTube channel, so all those lectures regarding sessions, timetable, everything you will be getting updated. And not only that, during the class, whatever faculties will write, okay, on the digital board, this soft copy we are going to share in the form of PDF in this particular channel, in this particular Telegram group we will share. Okay, the moment session is over, our faculty will share the lecture PDF. Okay, and in addition to that, whenever any seminar or webinar we are conducting, so regarding that updates also we will share in this Telegram channel. Okay, and then whenever PSU and government job notifications are releasing, our faculties, okay, so from our institute Okay, we will do the video, and regarding that notification also you will get whenever PSU job or any other government job notification. You don't need to search here and there. Okay, if you join our Telegram channel, you are getting these many benefits. And not the least, on daily basis our faculty will provide one question. Okay, say for example today one faculty will post one question related to one subject. Okay, tomorrow another faculty will post one question related to other subject, like that. Okay, so all you people can be participate in this quiz actively, and you can, here 4 options will be there, right? So among those 4 options, one option will be correct. You can choose whichever option you, after solving that question, you can mention, and the very next day our faculty will provide the solution for that quiz. Okay, so that means you are getting one opportunity that on daily basis you are learning one new question. Okay, so in that way you are getting great learning if you are joining our Telegram channel. Okay, so I hope all of you will join, whoever not yet joined till now. Okay, right. So now we are going to start regarding today's session, that is smart revision on digital circuit subject. So as I mentioned earlier, currently this session will be up to 3 o'clock, and then we are having one more session on today itself, 3:30 to 5. Okay, so in these 2 sessions I am going to cover the entire digital circuit subject, which is common for all the 4 branches: EC, electrical, instrumentation, computer science. I hope all of you are eagerly waiting for the session. So let us start. So the first chapter is number systems and codes. First chapter is number systems and codes, right? Say for example, if you are having a number belongs to base R number system. Okay, base or radix we will represent with the letter R. Okay, so in general in this entire digital circuit subject we used to represent, okay, the numbers in this particular format. Okay, whatever the number you are having, that number will specify in the brackets, and that number belongs to whichever base that will mention in the suffix. Okay, say for example if the base of the radix, if base or radix of the number system is R, then the maximum value that we can represent here, this is the base or radix. Base or radix of the number system is R. Then the maximum value that we can represent for a single digit, for every single digit, the maximum value we can represent is R minus 1. Okay, starting value is 0. That means we can represent any value ranging from 0 to R minus 1. Okay, say for example you are having a number belongs to base 10, that means decimal number system. That means for every digit of decimal number system you can represent the starting value from 0 and the maximum value is 9. That means 0 to 9, any possible value can represent like that. Okay, so here regarding the number systems, the conversions are very important. Number system conversions are very important. So regarding that, first one is decimal to any other number system conversion. Decimal to any other number system conversion. Decimal to any other number system conversion, right? So say for example regarding the decimal, if you are having integer part, if you are having only integer number, okay, for that integer part, in order to get the corresponding other number system equivalent value, we have to perform repetitive division operation. For integer part we will perform repetitive division operation. Repetitive division operation we will perform. And then whatever the reminders you are getting, those reminders will consider in the reverse order while you are placing the digits from left to right. Okay. Similarly for fractional part, if you are having fractional number, so that time exactly opposite process we have to do. Since we have done repeated division earlier, now we have to perform repetitive multiplication. So earlier we have done repeated division, so for every iteration you will get the remainders, right? So those remainders we have considered in the reverse order. Here, while you are performing the repetitive multiplication, okay, you will get the integers to the left of the radix point. Whatever the integers we are getting, we will place after the radix point in the same order, okay. And here regarding repeated division, up to what step we have to do? It is very simple. While you are performing the repeated division, the moment you are getting quotient as 0, you can stop the process. Whereas for repetitive multiplication, okay, after doing few iterations, if you are getting all the digit values are zeros, you can stop the process. Or sometimes even if you are performing repetitive multiplication after few iterations, still if you are unable to get 0, okay, you can continue that particular repetitive multiplication operation based on the given choices. Okay, based on the given choices, after the radix point, how many digits you are having, so that many times you can perform the repetitive multiplication, because for every repetitive multiplication you are getting one integer to the left of the radix point. Okay, so in this way, when the given number is real number, that time you will be having both integer part and fractional part. So first of all, you have to do for integer part conversion, and similarly for fractional part conversion, and then you can combine. Okay, so for integer part, whatever the equivalent value got, you can place, and similarly for fractional part, whatever the equivalent value got, you can place. So that is the equivalent number belongs to so and so base, okay, regarding your decimal number. Okay, so this is about decimal to any other number system conversion, and similarly any other number system to decimal. Next one is any other number system to decimal conversion. Any other number system to decimal number system conversion. Say for example, you are having a number belongs to base r. Suppose I am considering it is having both integer part and fractional part. Okay, suppose for the timing I am considering integer part 4 digits and fractional part 2 digits. Okay, so this number I want to convert into equivalent decimal number format. Okay, so that time what we have to do here first focus regarding integer part. Okay, you start from the radix point, go towards left hand side. The positional weights will be increasing powers of the base, r power 0, r power 1, r square, r cube. Similarly, for fractional part, start from radix point, go towards right hand side. Here the fractional part, here the positional weights will be negatively increasing powers of base r. Okay, so here you have to multiply each and every digit with the respective positional weight, and then we have to add. So from there you will get the equivalent decimal value or equivalent value, both are same. Okay, if you are having suppose base is x, okay, from there you are getting equivalent value. Okay, suppose if they have given base value as 5 or 6, 7, any number, from there you are getting the equivalent decimal value or equivalent value, both are same. Okay, so in this way, when you are having integer number, you will convert the decimal form into other number system. This is the procedure. Okay, now any other number system into decimal, this is the procedure. Okay, now you can observe, even sometime you might be getting some confusion or doubt during the GATE exam, whether we have to perform division operation or whether we have to perform multiplication operation. The reason is very simple. Even if you are getting slight confusion, you can cross check. Okay, say for example, if you want to get base 5 number, okay, so base 5 number means for any particular digit in the base 5 number system, you can represent the values ranging from 0 to 4. Now just apply one logic. whatever the integer number you are having, any integer number belongs to decimal number. Okay, if you are performing division operation, what are the possible remainders you will get? What are the possible remainders you will get? 0 to 4, right? So that means you are getting the integers belongs to base 5 number system. That's why we have to perform repeated division. Or in other words, you can cross check from here also. You can cross check from here also. Here you can observe for integer part. For integer part, say for example from this position weight to this position weight, how you are getting? By multiplying with r. Similarly from here to here by multiplying with r. From here to here by multiplying with r. So that means for integer part you are performing here repetitive multiplication. That means exactly opposite for earlier case. Exactly opposite for doing the reverse conversion, right? Similarly here, if you observe from here to here, r power minus 1 become r power minus 2. That means division operation is performing, right? Repeated division operation here performing. So exactly opposite, that is repetitive multiplication. In this way also you can cross check so that you can avoid any confusion if you are getting during the GATE exam. Okay. So in this way you can convert decimal into any other number system into decimal number system. Okay. And then next conversion is base r to base r power n conversion. Base r to base r power n conversion. Similarly vice versa. Say for example, you are having n number of digits. You are having n number of digits belongs to base r. You are having n digits belongs to base r. Now by doing the grouping of n digits, you will get the digits corresponding to base r power n. Base r power n. By doing the grouping of n digits of base r, you will get the one digit corresponding to base r power n. Similarly, if you want to do the reverse conversion, each and every digit of base r power n you can represent with n bits in the corresponding base. Just like binary to octal. Octal means 8. 8 you can represent as 2 power 3. That means you are doing the grouping of 3 bits, you are getting octal digit. Similarly, if you are having octal digit, you can represent each and every octal digit with 3 bits. Okay. In that way we can do the conversion base r to base r power n. Base r to base r power n. Okay, so this is about number system conversions. And then next topic is basic arithmetic operations. Basic arithmetic operations. So I hope all of you can answer. So can you mention in the chart what are the basic arithmetic operations? So whoever watching this session live, so all of you can mention to which branch you belong to among EC, electrical, instrumentation, computer science. Whoever watching this session later also, you can mention in the chart, in the comment section you can mention, so whichever branch you belong to and what is your target year. Yes, I hope all of you can easily answer. Basic arithmetic operations are addition and subtraction. Addition and subtraction. So these two are the basic arithmetic operators. Addition and subtraction, right? Say for example, whenever you are adding two digits of any number system, if you are able to represent, as long as the resultant sum is less than or equal to maximum value of that particular digit of that particular number system, then you can represent with the help of single digit. So that one we will call it as sum digit. But whenever the resultant sum exceeds the maximum capacity of that particular number system for a single digit, obviously we require one more additional digit, that is called carry. So whenever we used to get carry, okay, as long as you are able to represent with the help of single digit, that time there is no carry. That means carry value will be 0. But whenever we require carry, we always represent carry value as 1. Yes, Jitendra, you are from electrical. Okay, right. So carry we always represent 1 whenever we require one more additional digit, right? But the equivalent value of carry is nothing but base of the number system. Equivalent value of the carry is nothing but base of the number system. Base of the number system, right? See, it is very simple, just like here you can observe. Like here, forget about this fraction part, you are having integer part, r power 0, r power 1. R power 1 is nothing but r, so which is nothing but base of the number system. Similarly, while you are performing the subtraction of two numbers, okay, suppose I am assuming that here first number is having 2 digits and second number is having 1 digit. That means just by looking at that, you can understand that the first number is greater when compared to the second number. But somehow or other, while you are performing subtraction, okay, you will start from rightmost side, then digit by digit you will perform. Okay, suppose if you are subtracting smaller digit from larger, direct subtraction possible, like 9 minus 6 possible. But suppose if you are getting 6 minus 9, not possible. That time we have to borrow from the next higher digit. See, while you are performing the addition, we may require one more additional digit, that is called carry. While you are performing subtraction, we may require borrow. Whenever we are subtracting larger digit from smaller digit. Okay, that time we require borrow, right? So the equivalent value of borrow, here just like carry we are placing 1. Similarly, when you are taking borrow value will be 1. But equivalent value of borrow is nothing but base of the number system. Right? While you are performing addition, you may require carry. While you are performing subtraction, you may require borrow. The equivalent value of carry, equivalent value of borrow, both are same, which are nothing but base of the number system. Okay, so this is one of the important note point. Okay, and one more thing, while you are solving the questions regarding base or radix, they will give one equation. They will ask that identify the base value. Suppose if you are having one quadratic equation. After solving that equation, if you are getting two roots, okay, suppose one of the root is negative or 0, straight away you can eliminate. Whichever root you are getting positive and non-zero, straight away that will be the valid base. But suppose after solving any equation, if you are getting more than one possible solution, and among all those values, if you are getting positive and non-zero, then which root we have to consider as valid base? So for that, one of the important note point, so always we have to apply this condition. Always we have to verify whichever solutions are satisfying this relation, all are valid bases. Okay, so base of the number system R should be greater than or equal to maximum value of a single digit plus 1. Maximum value of single digit plus 1. So this is one of the important relation. They never mention in the question anywhere, but you have to verify. Say for example, after solving one equation, you got two roots like 3 and 5. Okay, but suppose in the question, suppose just for example I am telling, so you are getting base R equal to, suppose 3 and 5 you got after solving the equation. Suppose in that equation you are having multiple numbers. Suppose I have considered one of the number like this. Okay, suppose you are having in that equation like this. Now you can observe. Here, suppose if you are considering base is 3, you can represent 2 and 1. Is it possible to represent 4? Not possible. In base 3 number system, we cannot represent base 4. Suppose if you are considering 5, in base 5 number system, you can represent all the 3 digits. So valid will be 5, like that. Okay, in some cases, even if you are getting more than one possible solution, if this relation is satisfying, then all those are valid bases, like that. all those are valid bases. Suppose here you can observe among all the digits 4 is the maximum, right? So 4 plus 1 is 5. So R value minimum is 5 and more than 5 even any value is satisfying. Like that, whatever the theoretical equation you are having, from that you should get the solution, and after that you have to verify this condition. Both whichever are satisfying, all those are valid base. That's all. This is very, very important. Nowhere in the question they will specify regarding this one, but you no need to by heart or you no need to remember this condition. It is very simple. Whatever theoretical solution you are getting, just substitute that base value here. In that base of the number system, whether we can represent all those digits or not. If you are able to represent, then it is correct only. If you are unable to represent, that is not valid base. That's all. That is not valid base. Okay, so up to here we have discussed regarding number system conversions, basic arithmetic operations, and regarding the base important conclusion point. And regarding the number systems, we are having one more important topic, that is data representation. Next topic is data representation. So here, whatever the numbers we are having, in general we can classify into two types. One is unsigned numbers, another one is signed numbers. First one is unsigned and second one is signed. As the name implies, here we are not representing any sign in front of the number, whereas here we are representing sign in front of the number. Okay, so here all the bits will give the magnitude of the number. All the bits will give the magnitude of the number, right? Whereas here regarding signed numbers, we are having three forms. One is sign magnitude form, and next one is ones complement form, and one more form is twos complement form. Sign magnitude, ones complement, twos complement. Okay, so here just observe sign magnitude form. So here the starting bit, or we can say leftmost bit. Okay, leftmost bit we are reserving for sign bit. If the sign bit is 0, which indicates positive number, if the sign bit is 1, which indicates negative number, and remaining bits give the magnitude. Okay, that is the representation for sign magnitude. Okay, now whatever the representation you are getting for all positive numbers as per sign magnitude form, the same representation is applicable in ones complement and twos complement for all positive numbers. Okay, for all positive numbers, whatever the binary number you are getting as per sign magnitude notation, the same notation will applicable in ones complement and twos complement. But regarding negative numbers, the representation may vary. Okay, suppose if you want to represent negative number in ones complement form, first of all you have to take positive number, you have to apply ones complement. Similarly, for twos complement also, if you want to represent negative number, you can consider positive number. For positive number, you can apply twos complement. Okay, twos complement is nothing but ones complement plus 1. Twos complement is nothing but ones complement plus 1. Now all of you tell me, I will write the two statements on the board. Whether those two statements are same or different, all of you please confirm. Twos complement representation of a number, and the other one is twos complement of a number. Jitendra and other students, please confirm whether these two statements are same or different. Twos complement representation of a number, twos complement of a number. Any guess? See, our class is digital, right? So whoever thinking that these two are same, you can mention same. Okay, whoever thinking these two are different, you can mention different. Whoever having dilemma, it seems to be same, but at the same time it seems to be different. Even if you are having like that category, you can mention. Whatever you feel correct, you can mention, because there is no native marking, right? Because it is a class. So all of you can share whether these two statements are same or these two statements are different. It is very interesting, because in this particular chapter, whenever you are attempting any question, yeah, first time you are studying. Okay, so what is your target year, Jitendra? Are you targeting for next year GATE exam? Actually, currently, whatever the session is going on for the 2024, whoever writing the GATE exam, okay, because for them I am giving the quick revision, okay, or smart revision we can say. Okay, in the less time I am giving the complete recap of the entire digital circuit subject. Okay, so you can attend this session based on the possibility whatever you are able to understand, you can, okay, later, okay, if you are targeting for 25, 26, okay, so we are having already regarding digital circuit subject in our YouTube channel. You can refer the foundation course series. Okay, in that playlist you will be having the basic lectures in the sequence. Okay, from I started from number systems, and then Boolean algebra, K-maps, logic gates, like that in the sequence will be there. Whatever the basic concepts are there in our digital circuit subject, there you can go through. There are 16 videos are there. Okay, you will get what I mean to say regarding the digital circuit subject in the basic level onwards. You will get the confident and you will get the command over the concept. Okay, currently if you observe, I might be going little fast. The reason is very simple, because all the GATE aspirants who are targeting for 24, they are having less time, right? So that's why, and generally students will face, especially in this point of time, they are having their notes, but if they want to revise from their own, it will take more time. That is the reason here we are doing the revision of the complete subject in 3 hours, so that people whoever attended already and whoever done enough number of rounds preparation from their notes, okay, they will get in 3 hours time, they will get the complete revision, and what are the important formulas, synopsis, everything is there. But no problem, you can attend this session based on the possibility, try to attend, try to understand. But more details if you want regarding each and everything, just you can watch our playlist regarding foundation course, okay, in your free time, right? So here 2's complement, representation of a number, 2's complement of a number, these two are different, both are not same, See here, most of the students regarding this particular statement, most of the students, they will get correct answer regarding this one, there is no doubt about it. But only some students will do mistakes here regarding the first statement. Generally some students will do the mistake. Okay, see here, just observe 2's complement of a number. That means if you are having positive number, it will become negative. If you are having negative number, it will become positive, vice versa. Whereas 2's complement representation, that means if they are asking to represent positive number, that means sign bit should be 0. The moment sign bit is 0, remaining bits simply you can consider magnitude. That's why I have told, whatever you are getting for positive number as per sign magnitude form, the same representation is applicable in 1's complement, 2's complement. Okay, suppose if they are asking to represent negative number in 2's complement form, okay, that time what you have to do, you have to consider the positive number and then you have to apply the 2's complement. From there you are going to get negative number. Okay, from there you are going to get negative number. Okay. So regarding the range of the numbers, suppose if you are having n bits, here the range will be 0 to 2 power n minus 1. In general, if you are having n bits, you will get 2 power n combinations. Since we are starting from 0, maximal will be 2 power n minus 1. Next, coming to sign magnitude and 1's complement form, the range will be same. Here you can observe, whatever the number of bits you may consider, among those we are representing or we are reserving the leftmost bit for sign. The moment you have reserved 1 bit, the remaining bits how many? N minus 1 bits. Okay, with the help of n bits you are getting the maximum value this one. So with the help of n minus 1 bits, with the help of n minus 1 bits, in place of n you can substitute n minus 1, in place of n you can substitute n minus 1. Okay, so this is the negative maximum and this is the positive maximum, that's all. This is the negative maximum and this is the positive maximum. And coming to the 2's complement, okay, just now we have mentioned positive numbers representation is same in all the three forms. That is the reason regarding the maximum value, that will be as it is, upper limit as it is. But what about the lower limit? You can observe in sign magnitude and 1's complement we are having two different representations for plus 0 and minus 0, whereas in 2's complement form you are having unique representation. That is the reason you are getting one negative number extra in 2's complement when compared to other two, right? So here since you are getting one negative number extra, so that means here minus 1 you can avoid, you don't need to separate that one, that's all. Minus 2 power n minus 1 2 plus 2 power n minus 1 minus 1. Yeah, next one, say for example, for easy understanding, whatever these two statements I have told, just in order to get more clarity, suppose if they are asking to represent plus 6 in 2's complement form. Here positive number is there, that means sign bit is 0. The moment positive number is there, remaining bits give the magnitude. 6 is nothing but 110. 6 is nothing but 110. Right. Now, if you want to represent minus 6 in 2's complement form, you can apply 2's complement to positive number. 2's complement to positive number. Okay. So here 2's complement of plus 6 is nothing but 0 110. Now you can apply 2's complement to this one, 1's complement plus 1. 1's complement you will get 1001 plus 1. So from here you will get 1010. Now you can observe, you are having negative number, okay, but I have considered positive number. For positive number, if you are applying complement, you are getting negative number. Similarly, whatever negative number you got, just apply 2's complement, you will get positive number, okay. But whenever they are asking to represent plus 6, that means positive number sign bit should be 0, remaining bits give the magnitude. Whereas regarding negative number, we will take positive number and we will apply corresponding complement, okay. This one approach, and one more approach. Here, suppose sometimes they will give one binary number like this. They will give, and in the question they will specify that number already represented in 2's complement form, and they are asking the corresponding equivalent decimal value. Okay, that time what you have to do, just like the unsigned case, put the position weights in powers of 2. 2 power 0, 2 power 1, 2 square, 2 cube. Right. Here sign bit is 0, consider positive. Okay, by default anyway here we have considered positive position weights only. By default we have considered positive position weights. Okay. Now here sign bit is 1, it indicates what? Negative. So the corresponding position weight you have to consider minus. Okay. So here you are getting 0 110 is nothing but 6. Since sign bit is 0, the corresponding position weight we have considered plus. Okay. Regarding the resultant equivalent value you have to consider positive number, that's all. So 110 is nothing but 6. So plus 6 base 10. Okay. Similarly here minus 2 cube is nothing but what? Wherever ones are there, just add the respective position weights, that's all. Wherever ones are there, just add the respective position weights. Minus 2 cube is nothing but minus 8 plus 2 power 1. From here you are getting minus 6. So in this way we can calculate directly the equivalent decimal value whenever they specify the given number already represented in 2's complement form. Okay, I am repeating once again, the moment if sign bit is 0, you consider positive number, remaining bits give the magnitude. Okay, the moment sign bit is 1, that means corresponding position weight is minus, wherever ones are there, just add the respective position weights. Okay, and similarly here, suppose for represent plus 6 we require 4 bits. For representing minus 6, we require 4 bits. Suppose the same number if you want to represent with 5 bits, what we can do? We can place one more bit to the left of it, the same bit, sign bit 0. Similarly, if you want to represent 6 bits, the same sign bit you can place 2 more times. Similarly here, for negative number, sign bit is 1, so that sign bit you can place n number of times to the left of it, the equivalent value won't change. So in simple words, I can say this is the sign extension property. This is the sign extension property. Say for example, I am having a number x3, x2, x1, x0, a 4-bit number, the same number I am representing like this. Okay, this number I have copied as it is. Now, suppose if the number is positive, that means x3 will be 0, the same 0 I have kept. Suppose if the number is negative, x3 is 1, so accordingly I have placed. So whatever the given number is there, if it is already represented in 2's column form or 1's column form, whatever the leftmost bit, sign bit is there, that same sign bit you can place n number of times to the left of the sign bit, the equivalent value won't change. That is called sign extension property. And similarly you can apply reverse. Suppose they have given one very long binary number like this, and if they specify that this number is represented in 2's column form, they are asking the equivalent value. Okay, so this entire number is same as this number. This entire number is same as this number, because you can observe here you are having total here 4 times x3 and then here 5th time. Okay, but here if you observe 1 time x3 is there. Okay, so for this number whatever the decimal equivalent you are getting, for this number whatever the decimal equivalent you are getting, both will give the same answer. Okay, if you want you can give a try later, but during the gate exam to save the time, whenever they are giving long binary number like this, if you are supposed to find the equivalent decimal value, especially when it is represented in 2's column form, just observe how many times that leftmost bit is repeated. So just by observing from here, okay, after that this particular bit is simply repeating, right? So you consider this part of the number. For this number, find the equivalent value. The same answer will be there for the entire binary number. Okay, especially I am talking, this is represented in 2's column form. Okay, next one, say for example, whenever you want to perform subtraction of two numbers in 2's column form, a minus b. So that time we can write this one as a plus of minus b, and minus b we can write it as 2's complement of b. Minus b we can write it as 2's complement of b. So that means here 2's complement of b, you are having b is one number, for that number you have applied 2's complement, that entire number you can assume something like x. Now you are adding a and then x, that's all. Okay, that is the advantage of 2's complement. Whenever you want to perform subtraction of two numbers, you don't need to check whether a is greater than or equal to b or a is less than b, whether we have to take borrow. All these difficulties you can overcome. Okay, just you are converting subtraction of two numbers like addition of two other numbers like that. Okay, but now suppose for easy understanding, a plus, suppose this is like x I have considered, 2's complement of b I am considering as x. Okay, now you are adding two numbers, right? Now you are adding two numbers. Okay, suppose I am considering all the possible cases regarding a and regarding x. Here I am performing addition only. In all the 4 cases I am performing addition only. Now just observe all the 4 cases. I am performing a and x. Okay, I am performing addition of two numbers, right? Now here both are positive, that means I have to get the resultant answer as positive. Resultant answer should be positive. Here both are negative, resultant answer should be negative. Resultant answer should be negative. Now if you observe carefully, in these two cases here I am performing addition of two positive numbers, here I am performing addition of two net numbers, right? Actually I am performing here addition operation. Okay, so in these two cases I am performing addition operation. Okay, addition of two positive or two negative. So if you are having individually n bits, the resultant sum, in order to represent, at most we require n plus 1 bits. At most we require n plus 1 bits in order to take care about the sign bit. Okay, whereas here you are performing addition of two numbers, but one is positive, another one is negative. Here also one is positive, another one is negative. That means actually what operation here you are performing? Any guess? You are adding one positive number with negative number. That means you are performing actually subtraction operation. It seems to be that you are adding, but ultimate resultant output, if you observe, it is like subtraction. When you are performing subtraction, that time whatever the n bits you have considered, that will be more than sufficient to represent the resultant sum. Resultant sum. Okay, so this is about data representation regarding sign magnitude form, 1's complement form and 2's complement form. So among all, the 2's complement is very important. Sometimes they will ask regarding sign magnitude and 1's complement also. Okay, so regarding this concept, either they will ask regarding representation of numbers, or they will ask the equivalent value, or they will ask the range of numbers, or maybe addition or subtraction of numbers, etc. Okay, and the last topic of this first chapter is binary codes. Binary codes. So among that we are having the first code is BCD code. BCD code. The full name of this one is binary coded decimal. The other name of this code is 8421 code. BCD code or 8421 code. So here this particular code we are using for representing decimal digits. For since we are having 0 to 9, for a single decimal digit 0 to 9, 10 possible values are there. For representing any of the value, okay, or we can say for representing 9 we require 4 bits. That is the reason we are representing for every decimal digit with the help of 4 bits. That's why it is mandatory that by using BCD code or 8421 code, each and every decimal digit we have to represent with 4 bits. Okay. Next, coming to the XS3 code. XS3 code is nothing but whatever the BCD code you are getting, so just add 3. BCD code plus 3. You can observe here XS3. 3 already has been XS, right? So that's why you are representing the code in such a way that 3 already you have included. Okay. So just like the BCD code, XS3 code we are using for decimal digits. So these two are the examples of sequential code. These two are the examples of sequential code. Okay. Next one, that is gray code. Gray code, it is an example of, gray code is an example of unit distance code. Gray code is an example of unit distance code. Gray code is an example of cyclic code. Gray code is an example of unit distance code. Gray code is an example of cyclic code. So here in this gray code, we are keeping the code in such a way that any two successive codes you can consider, only one bit will get differed. And in fact, one more interesting thing, the first code and last code, okay, even those two are also differed by only one bit. That's why we are telling gray code is an example of cyclic code. Now coming to the binary to gray code conversion and gray code to binary conversion. Binary to gray code conversion and gray to binary conversion. Say for example, I am considering 4 bits. It will applicable for any number of bits, any number of bits. Suppose you are having the binary number here. Now we want to get the corresponding gray code. Okay, here whatever the first bit or leftmost bit you are having, you can copy as it is, copy as it is. and then you can perform XOR operation like this, and then you can perform XOR operation, sorry, on successive bits. XOR operation you can perform on successive bits. So this will give binary to gray code, binary to gray code conversion. Similarly, you can consider gray code. For the timing I am considering 4 bits. See, whatever the first step we have done here, same thing. Whatever the leftmost bit is there, you can copy as it is. That is the first step in both the binary to gray and gray to binary. Now, coming to the binary to gray, we have performed XOR operation on successive bits, whereas here we will perform XOR operation diagonally like this. Okay, we will perform XOR operation like this. And from here we are going to get binary code. From here we are going to get the corresponding binary code. Yes, Gautam, regarding first chapter, okay, you may get the questions related to the number system conversions, that is a direct question, or while you are solving the question, the number system conversions logic may help. Okay, like that also they can ask the question. And then regarding data representation, they will ask the question regarding 2's complement or 1's complement or sign magnitude. Okay, or they will give some numbers like addition operation or subtraction operation in the corresponding 2's complement form. Okay, and then regarding binary codes, they will give any question regarding BCD code or XS3 code or similarly gray code. Regarding gray code, they will give binary code and they will ask the corresponding gray code, or they will give gray code, they will ask the corresponding binary. Or this concept binary to gray or gray to binary, even if they want to frame any question, they can frame the question combination circuits chapter. They will give one circuit. They will give one circuit and they will ask that identify the circuit. Okay, in that whatever the codes you have learnt, or whatever the representation of numbers you have learnt in the first chapter, so regarding that conversions, based on that they will give the circuit, that time you can verify like that. Okay. Yeah, Gautam, in this particular session, we are doing the complete revision of entire digital circuit subject in this session, and after we are having one more session today. Okay, in these 2 sessions together, we are doing the complete revision of this particular subject. So, if you want what are the expected questions for your coming GATE exam regarding this particular subject, so in your free time, just refer at our IMS Gate Academy YouTube channel. Just go through the playlist regarding GATE score booster sessions. Okay, before this series, we have done GATE score booster series. So in that series, you can refer the whatever the questions we have discussed there. Okay, our faculties discussed regarding whatever the questions we have discussed there. Those are the most expected concepts, most expected models for your coming GATE exam. Yes, Gautam. Yeah, if you are from EC branch, regarding this particular subject, you will be having the weightage around 7 to 8 marks. Similarly, for instrumentation also, you will be having 8 to 10 marks. And whereas for computer science or electrical, the weightage of this particular subject is 4 to 5 marks. Yeah, for EC it will be 7 to 8 marks, 7 to 8. Yeah, with this we have completed regarding first chapter. Now let us start the second chapter. Chapter 2, that is Boolean algebra and K-maps. Yeah, in general, whenever you are having any circuit or system, okay, you can inside any, especially I mean to say digital circuit, okay, you will be having inside any circuit, you will be having logic gates, right? Inside every logic gate, you will be having so many electronic components, among which the one of the main electronic component is transistor, right? So transistor, when you are studying EDC or analog circuit subject, you might have studied various applications with respect to transistor, but here coming to our digital circuit subject, the transistor, one of the application we will see like on or off. That means closed switch or open switch, right? So that means if we are connecting switches in series, then among those variables we can perform logical AND operation. Similarly, if the switches are connected in parallel, then we can use logical OR operation among the variables. And whatever might be the bigger circuit or system you might be having, by the combination of logical AND, by the combination of logical OR, wherever required you can use AND operator, wherever you require you can use OR operator. In addition to that, sometime if the variable is normal, you can represent as it is. If the variable is complement, you will represent complement of that variable, like that. Okay, so in that way you can represent. Now the next one is duality principle. By interchanging logical AND and logical OR operators. So here we will interchange logical AND and logical OR operators. We will interchange logical and logical OR operators. Similarly, one more step we will perform, zeros and ones. Zeros and ones we will interchange. Then if you are doing like that, whatever the function you are going to get, that is a dual for first one. Okay, that is a dual for first one. Suppose you are having one Boolean function f. Okay, after applying dual, you are getting the function as fd. In general, the dual function and original function both are not same, because initially in the function wherever AND is there, you are replacing with OR. Suppose you are having AND gate. AND gate dual is what? OR gate. Similarly, OR gate dual is AND gate. Similarly, like that. Okay. But in general, you will get the dual function and original function both are like different. But in few cases, you may get the original function and the dual function both are same. Okay. If it is so, then we will say it is the self dual. If it is, then we will say that function as self dual. Self dual means very simple. The function itself is the dual. Say for example, regarding self dual, suppose you are having the function like a or a bar, b, b bar. Like that, if you are getting any one function, you can consider. Okay, because here first step what we have mentioned, logical and logical OR operators we have to interchange. These two operators generally will perform among two variables, but here how many variables you are having? Only one. When there is only one variable, there is no question of interchanging the operator, right? So that is the reason for a, if you apply dual, you will get a only. For a bar also a bar. For b, b. For b bar, b bar. That means the original function and the corresponding dual both are same. That is the reason we are calling it as self dual. Next one, commutative law. Say for example, when you are having two variables x and y, among which suppose I am performing logical AND operation. Okay, here x and y have considered. Now I have interchanged the variables order. Then if you are performing the same operation, then if you are getting equivalent, if the left hand side and right hand side both are equivalent, then we will say that operator is satisfying commutative law. Next one is associative law. Suppose here I am considering three variables. See, here I am having three variables, here also three variables, right? Here I am performing among y and z first and then with x. Here among x and y first and then with z. That means whenever you are having three variables, on any two variables you can perform that operation first and then with third variable. Then we can say it is satisfying associative law. And here if you observe, same operator I have considered. Same operator. Now the next one is distributive law. So here I will consider both the operators. Among the three variables, I will consider both the operators, like x and y plus z is equal to it is just like normal multiplication, xy plus xz. So most of you are very much familiar regarding this one. Okay, x and y plus z equal to xy plus xz. Okay, so here whenever you are having LHS like this, you can write RHS. Similarly, sometimes you may be having RHS. Okay, yeah, regarding this one, okay, I will apply dual. After that I will explain. Regarding dual, x and, here x and is, wherever and is there, you have to replace with r. Okay, x plus y and z, x plus y and z. Wherever logical and logical, wherever logical, logical, right? Then regarding x and y, x plus y, here logical, logical, then logical and logical. Okay, by replacing logical and with logical OR operators, by replacing logical OR with logical AND, we will get the dual function. Okay, so regarding this one, most of the students will easily apply, but regarding this one, few students will face some difficulty. Okay, it is very simple. Based on the requirement, you can apply LHS to RHS or RHS to LHS, vice versa. Okay, see here, just like here, x and y plus x and z, right? So in the similar way, x plus y, that is the first term, and x plus z, like that you can write. Similarly, if you are having RHS term, you can write LHS. Okay, how easily we can write? It is very simple. Just observe both the terms. Just observe the common part. X plus is same, x plus is same. So first of all, write that part as it is. X plus as it is you can write. Now whatever the leftover variables are there, among which you can perform this operation, logical AND. So from there you are going to get this one. Okay, so based on the requirement, you can apply regarding distributive law LHS to RHS and RHS to LHS. Now with this understanding, can you tell what is the answer for this one? And similarly, what is the answer for this one? All of you give a try. For easy understanding, I have given two equations, simple equations. See here, A into A, that is A plus A into B is AB. So from these two you can take A as common, 1 plus anything is 1, logical OR. Okay, so directly you can remember like this is formula, A into A plus B equal to A. Here A plus A bar B. See this one I have got based upon this formula, right? So this one based on this formula, A plus A bar, you will get 1, so A plus B, directly you can write A plus B. You can remember most of the time while you are simplifying the Boolean functions, okay, you may require, see regarding combinatorial law, associative law, most of the people will do correctly, but regarding distributive law, this equation also most of the people will do correctly, but regarding this equation only sometimes few students will do facing problem. Okay, but I have already told how to remember LHS to RHS, RHS to LHS. With the help of that logic, you can easily answer. Yes, very good, Jitendra. See, A plus A bar equal to 1, so you will get A plus B, A plus B. Okay, so the next one, next law, that is one of the most important law in the entire Boolean algebra, and in fact that is, I can say, one of the, that is a powerful law of entire Boolean algebra. So that is consensus law. Consensus law. Xy plus x bar z plus yz is equal to xy plus x bar z. See here, regarding consensus law, you should not remember the equation. Rather, two conditions will be there. If the two conditions are satisfied, then we can bring three terms into two terms. Okay, so here you are having three terms. Okay, so for the timing, just consider the last term. This term could be anywhere. Okay, but in this equation, the term was there in the last. Okay, just observe the last term. Here y and z are present, right? So y is present in this particular term and z is present in this particular term. Okay, so the first and foremost condition, whenever you are observing term by term, okay, in that particular term, whatever the variables are there, those variables should be distributed exactly in the same form. Okay, y can present here, z can present here, no problem, no problem. But in this example, y is present here, z is present here. Here in this particular term, what is the missing variable? The missing variable is x. That is present here normal, and in its complement form is present here. X can present here, x bar can present here, then also it will appear. Okay, so these two conditions are very important. If the two conditions are satisfied, then we can bring three terms into two terms. That means this is the redundant term. Even in the absence of this particular term, you will get the same functionality. You will get the same functionality. So that's why I have told, regarding consensus law, you should not by heart the equation. Rather, you have to verify whether these two conditions are satisfied or not. Okay, I hope it is clear for everyone. Whatever the term you have considered, in that term, what are the variables you are having? Suppose in this case, y, z are there, y is present here, z is present here. Suppose y bar, z is present. Suppose y bar can present here, z can present here, or y bar can present here, z can present here, like that. Whatever the variable, if you are having complement form, exactly same. If you are having normal, exactly same, like that. Okay, so this is consensus law. Next one, up to here, whatever the laws that we have discussed, you can use any of the laws while you are doing the simplification of any Boolean function. But whenever you are supposed to find the complement of any Boolean function, that time we can use De Morgan's law. So De Morgan's law we can use whenever we are supposed to find the complement of any function. So xy bar is equal to x bar plus y bar. So just apply dual to this one. You will get x plus y whole bar is equal to x bar and y bar. So here this De Morgan's law will applicable for any number of variables, but for the timing I have discussed for two variables. Whatever the variable here you are having, each and every variable will get complement. Each and every variable will get complement. Here if you are having logical and, here you will get logical. If you are having logical, you will get logical and, like that. Okay, next topic, that is Boolean functions representation. Boolean functions representation. So in general, from the truth table, whatever the output variables you are having, each and every output variable, okay, you can represent in the sum of minterms form, or you can represent in the product of maxterms form. So sum of minterms form. In general, sum we will represent with the symbol sigma, minterms we will represent with the letter small m. Okay, sum of minterms or sigma m form. So in general, product we will represent the symbol pi, maxterm we will represent with the letter capital M. So pi capital M form. Sum of minterms form or product of maxterms form. Okay. So these are the original functions. Either you will get sigma m form or pi capital M. After doing simplification, you will get SOP, simplified form, that is sum of products form. And after doing the simplification, you will get PYs. In general, most of the questions are, while you are doing the simplification, sigma m if you have considered, SOP you will get. If you are considering pi capital M, you will get PYs. Similarly, you can do the reverse conversion. Okay. In most of the questions, you can easily observe the given function, whether it is SOP or PYs. Okay. And here, if you are considering same output variable, you can represent in any of the four forms. Okay. In the initial standard form, any of the two. After doing simplification, any of the two. So total you are having four forms. Sometimes students will think that SOP and PYs are not same. Representation wise not same, but they are equivalent. Okay. And in fact, if you are considering one output variable, suppose y1 is a output variable function, For that, if you have represent sigma m, equivalent you will be having pi capital M, equivalent you will be having SOP, equivalent you will be having POS. That means for the same output variable, you can represent in any of the 4 forms. So that means regarding this particular format, okay, suppose they have given one function in the sigma m, suppose, okay, they can ask that identify the equivalent functions, okay. So in one choice they can give SOP, in one choice POS, in one choice pi capital M, in another choice maybe some other representation. So whichever options are equivalent for the given function, all those options you can choose as equivalent, because this question or this concept is having the scope of MSQ. Okay, for MSQ either one option or more than one option can be correct. Yeah, I am fine. Good afternoon. So how are you? What is your name? You are from CSE. Yeah. So in general, you can represent sigma m or pi capital M after doing simplification SOP, POS, and similarly vice versa. Similarly vice versa. Next one. Suppose if you are having n Boolean variables. Suppose if you are having n Boolean variables, then with the help of n Boolean variables, you will get 2 power n min terms, 2 power n min terms. Similarly, you will be having 2 power n max terms. Similarly, you will be having 2 power n max terms. Hi, Saki. Yeah. If you are having n Boolean variables, you will be having 2 power n min terms, you will be having 2 power n max terms. With the help of either 2 power n min terms or with the help of 2 power n max terms, you can generate 2 power n Boolean functions. 2 power n Boolean functions. Sum of all min terms. Sum of all min terms is equal to 1. Next, product of all max terms. Product of all max terms is equal to 0. Product of all max terms is equal to 0. Next, product of any 2 different min terms. Product of any 2 different min terms is equal to 0. Next, sum of any 2 different max terms is equal to 1. So these properties will help you while you are solving the questions based on sigma m form or pi capital M form when you are having. If you are adding all the min terms, then resultant value will get 1. If you are multiplying all the max terms, you will get 0. If you are multiplying any 2 different min terms, you will get 0. If you are performing addition of any 2 different max terms, you will get 1. Next one is K-maps. So for the timing, I am considering 3 variable K-map. Suppose you are having the function like this. Suppose you are having the function like this. Okay, I have represented 4 ones like this in the given K-map. Now first of all, in this K-map, you have to do all the possible groupings in decreasing powers of 2. In decreasing powers of 2. So you can do grouping of these 2 ones. You can do grouping of these 2 ones. You can do grouping of these 2 ones. Right, total 3 possible groupings are there. With the help of this question, I am giving the complete picture regarding K-maps. Okay. So here, when you consider this grouping, row wise x value is 0, x bar, and column wise z value is 1, z. You have to observe row wise and column wise, whichever value is constant, that you will, according to that notation will come. Okay, here row wise x value is 0, complement, column wise z value is 1, normal. Okay, next, coming to this grouping, row wise x value is 1 and column wise y value is 1, y. With this understanding, you can easily write regarding this grouping. In this grouping, column wise y value, z value both are equal to 1, so that means yz. In this way, for the given K-map, in the decreasing powers of 2, regarding adjacently placed ones in decreasing powers of 2. Say for example, it is a 3 variable K-map. We have to check from grouping of 2 power 3 adjacently placed ones. If possible, we can do combined grouping. If not possible, then go for 2 square. Here you are having 4 ones, but not all the 4 ones are adjacent. Suppose if you are having 1 here, we could have done grouping, or if you are having 1 here, we could have done grouping. Okay. So here, then go for 2 power 1, then go for 2 power 0. So here grouping of 2 power 1, 2 adjacently placed ones possible. Like that you are getting 3 groupings, do all the groupings. Yes, Isaki, I will cover that topic in some time. Yeah, definitely I am going to cover. So here after doing each and every grouping, what are the product terms you are getting, each and every product term we will call it as primeplicand. Initially I will call whatever the product terms we are getting like this, we will call each and every product term as primeplicand. Now we will check among these groupings which are compulsory. Say for example here, if you don't do this grouping, for this one there is no other grouping. That means this grouping is mandatory. This first grouping is mandatory, so that means it is essential. Okay, similarly, just observe this grouping. With respect to this one, this particular row grouping is mandatory, it is essential. What about this one? Suppose if you don't do this grouping, this one is having some other grouping, this one is having some other grouping, it is just primeplicand. Okay. So initially we got number of primeplicands equal to 3. Okay, as of now we got number of essential are 2. Okay, so what are the essential primeplicands we got? We will write in the minimized function those essential primeplicands. So that means here you will get x bar z plus xy. Now we will check whether this primeplicand we have to consider or not. Say for example, x bar z you are getting because of these two ones grouping, and xy you are getting because of these two ones grouping. In this K-map, total 4 ones are there. All the 4 ones are covered by these two essential. In that case, this primeplicand is not at all required. Okay, suppose due to any reason, some of the ones are not covered by any of these two. Okay, or neither of these two. Okay, then in order to cover those ones, we will consider the other primeplicand. Okay, but in this question, this primeplicand is not at all required. So minimized function means this one. Now, in the minimized function, you are getting these two, but that means this is eliminating. So that means this one now we can call it as redundant primeplicand. So always the number of primeplicands equal to number of essential plus number of redundant. Okay, in this case, total primeplicands are 3, out of which 2 are essential and 1 is redundant. Suppose if there is no redundant primeplicand, in that case the number of primeplicands, number of essential both are same. Provided if there is no redundant primeplicand. Okay. So that means here what is observation point from the help of this K-map? Here if you observe what are the K-map I have considered, if you refer whatever the consensus law we have discussed, same thing. Okay, regarding consensus law, if you are doing the simplification with the help of Boolean algebra or Boolean laws, okay, then you have to verify whether those two conditions are satisfied or not. Okay, or with the help of K-map, whenever they're asking the question regarding simplification, only simplification if they're asking, with the help of good number of questions practice regarding K-map, you people might have done only this grouping and only this grouping. You could have avoided this grouping, right? That is true. That is true. Okay. Just by observing the K-map, these two groupings are sufficient, right? So now you can observe initially you're having 3 terms, but finally you're getting 2 terms. Okay. These 2 terms are nothing but by using consensus law only you are getting, right? But whenever the question is regarding prime implicants or essential redundant, so that time we have to do all the possible groupings in this order, in the decreasing order. Okay, that is the most important. Okay. Now here, whatever the prime implicants you got, total 3, out of which 2 become essential. That means essential prime implicants are by default prime implicants, but all prime implicants need not be essential always. This is the most important conclusion point. All essential prime implicants are by default prime implicants, but all prime implicants need not be essential. All prime implicants will be essential provided if there is no redundant prime implicant. If there is no redundant prime implicant, in that case only we can say all the prime implicants are essential. Now suppose in some questions, in addition to ones, okay, suppose you might be having don't care symbol. That time how to do the simplification? For that I will show one question. Yeah, suppose you are having a function like this. Now here, whatever the don't cares are there, okay, if you are considering any don't care as 1, provided with the help of that, if you are getting the grouping of maximum possible adjacently placed ones in powers of 2, then you can consider that don't care as 1. Okay, otherwise you can ignore. Suppose for the timing, if you observe these 2 don't cares, if you are considering as 1, then you are getting what? Grouping of 4 adjacently placed ones. Okay, right. Similarly, here you are having 2 ones, here third one. Now if you are considering this don't care as 1, now we can do grouping of 4 ones like this. Okay, in this way we can do. Now regarding this row grouping, row wise x value is 0, that means x bar, column wise y and z values are varying, it won't come. Now regarding this grouping, column wise z value is 1, that means z value is 1 z. Now can you tell what is the final answer regarding the minimized function? All of you mention, we got here x bar, here we got z. Okay, whether the answer will be x bar plus z or x bar into z. All of you mention in the chart. What is the final answer regarding the minimized function, whether it is x bar plus z or x bar into z? Yeah, it is very simple. Just you can observe earlier one. Here we have done grouping of ones, right? So from each and every grouping, okay, we are getting what? Product terms. Those product terms we have summed together, right? So similarly here, whatever the product terms here you are getting, we have to sum together. But you might be having the confusion that, sir, how these are product terms? See, here you are unable to visualize these are product terms, but actually those are product terms. Okay, why you are unable to visualize? It is very simple. See, just observe here. Here we have done grouping of 2 ones. Since we have done grouping of 2 ones, one literal is getting eliminated, and because it is 3 variable function, among 3 variables, 1 literal gone. That means you are getting 2 literals, right? So that is the reason you are able to visualize these are the product terms. But here the moment you have done grouping of 4 literals, that means 2 literals gone. The moment, since you are having 3 variables, out of which 2 literals gone, that means only 1 literal is remaining. With the help of 1 literal, you are unable to visualize it is a product term, but actually it is a product term. Actually it is a product term, right? So since you are getting product terms, those two are summed together. Those two are summed together. Okay. Now, suppose due to any reason, okay, somehow or other you got some confusion during the GATE exam, whether I have to consider plus or whether I have to consider and, okay, which is the really correct, even if you are getting slight confusion. Now, whatever the question you are solving with the help of sigma m, same question you can solve with the help of pi capital M, right? So the final answer will remain same. The final answer after doing the simplification, if you are getting equivalent, that means if both are giving same answer, final answer, that means it is correct. Okay. Now, other than ones and don't care, you can put remaining places 0. Remaining places you can put 0. Now, here you can observe you are having 2 zeros. These two are adjacent. First column and last column are adjacent, right? First row, first column and last column are adjacent. But here you are having don't care, but here 1 is there. So that is the reason we cannot do grouping of 4. Okay. So only possibility is grouping of 2 zeros like that. Grouping of 2 zeros. Now, for this row wise grouping of 2 zeros, okay, with respect to row wise, x value is 1, that means x bar, whatever the notation you are considering for min terms, exactly opposite we have to consider for max term. Okay, x bar, then column wise z value is 0, that means normal, x bar plus z. See, in general, when you are doing the grouping of min terms, you will get product terms. Similarly, when you are doing the grouping of max terms, you will get sum terms. Now, in this K map, you are getting only one grouping. Suppose if you are getting more than one grouping, what is the sum terms we got, we have to multiply. Okay. But in this question, since you are having only one grouping of zeros, obviously that is the final answer. That is the final answer. So earlier I have mentioned that in most of the cases, in general, if you are having sigma m form, after doing simplification you will get SOP, right? Similarly, if you are having pi capital M, after doing simplification you will get POS. Okay. In general, how to identify whether it is SOP or POS? Okay, you can observe easily from here. See here, xy plus xz. Okay, xy plus xz. Here you are having product term, here also product term. These two are summed together. Okay, here you can observe. You are having sum term, here also sum term. These two are product together. So in general, SOP form, by observing the function, you can identify that product terms are summed together. Here sum terms are multiplied together. Okay, but so like that, in most of the questions you can easily visualize which is SOP, which is POS. Okay, but in few questions you will get after doing the simplification of the given K map or given Boolean function, what is the simplified function you are getting. Okay, if you want, you can visualize that is in SOP. If you want, you can visualize that is in POS. Both at the same time. That means without doing further simplification, both are giving the same answer. According to your wish, you can visualize in that manner. Okay, but don't get any confusion, especially in the GATE exam. Okay, suppose if you are getting like this question, if they are asking that, okay, identify the simplified function in SOP form or identify the simplified function POS form, don't go into the trap. Okay, I already told you that most of the times you can visualize it is in SOP form, it is POS form, but after doing further simplification, your SOP and POS ultimately giving the same answer, equivalent, both are equivalent, but representation wise looking like different. But in few cases like this, representation will be same in both SOP and POS. Now you might be having the doubt that, sir, how to visualize it is in SOP or it is in POS. Okay, I will show. Suppose if you want to visualize this is SOP, okay, what we can do here, x bar is there, right? Here yz missing. Suppose I am multiplying with 1 for the timing with 1. Okay, x bar into 1 is same as x bar. Similarly, z into 1 is same as z. now you can visualize this is product term, this is product term, these two are summed together. So that means the given function is in SOP. The simplified function is SOP. So we have considered sigma m. After doing simplification, we are getting SOP. Yes. Similarly, vice versa. Okay. So here, how to visualize it is the POS form. How to visualize it is POS form. See here what we can do. Here x bar plus 0. X bar plus, yeah, sorry. Yeah. So here x bar plus z, okay, I can multiply with what? 1. I can multiply with 1. Just like here, x bar I have multiplied with 1, z I have multiplied with 1, right? In a similar way, this function you can multiply with x. You can multiply with 1. The same answer you will get. So x bar plus z I am copying as it is. Suppose this 1 I am writing like y plus y bar. Y plus y bar anyway 1. So now you can visualize this is some term, this is some term. These two are what? Product together. It is in POS form. It is in POS form. So in general, in most of the questions after doing simplification of pi capital M, you will get POS. Similarly, after doing simplification of sigma m, you will get SOP. But in few cases, without doing further simplification, your answer, final answer will remain same with respect to sigma m or with respect to pi capital M. That time how to visualize whether it is SOP or POS, it is very simple. If you want to consider like product term sum together, multiply with 1 for every term, so that x bar into 1, that is like product term, z into 1, that is like product terms are summed together. Okay. Here I have to visualize as product of sum, that means sum terms product together, that means I have multiplied with 1, that 1 I have represented as some other variable, y plus y bar. Y plus y bar anyway 1 into x bar plus z is nothing but x bar plus z. I hope it is clear for everyone. This is the most important thing, but generally up to here, when you are solving the question, most of the students will do the correct regarding representation wise. But while choosing the correct option, okay, generally some students will be under the trap, okay, especially when they are mentioning the word SOP or POS. Because of that, during the exam hall, you might be in the confusing state, okay, while you are solving these kind of questions. That time, if they don't mention whether it is SOP or POS, damn sure whatever answer you are getting, that you will choose. But the moment if they are mentioning SOP or POS, that time since they are asking SOP, you may have to put and here, and if they are asking POS, you may put here and etc. Something like that. Because of that, some students may get wrong answer. Okay, that's why I have given the clarity. In most of the cases, SOP and POS representation wise looking like different, but in few cases, your SOP and POS are the final answer without doing further simplification will give the same answer. But if you want to visualize, this is the way to visualize it is SOP. This is the way you can visualize as POS. I hope it is clear for everyone. Yeah, Isaki, you have asked that regarding conversion of SOP to POS, right? Yeah, SOP to POS. Suppose you are having x plus yz, if you are having you can write x plus y into x plus z. Okay, SOP to POS conversion. SOP to POS. Here you are getting by using distributive law. This is by using distributive law. By using distributive law. Okay. Similarly, say for example, I am considering x bar y plus x y bar. Okay, this is what x exclusive or y, x exclusive or y, right? So this is in which form? SOP form. Product terms sum together. Product terms sum together, right? SOP form, right? So this one if you want to convert into POS form, this one if you want to convert into POS form. Okay, what you have to do here, x bar plus x if you consider, you are getting 1, right? See, x bar plus x is 1, that you can avoid. Then x bar plus y bar you are getting, x bar plus y bar you are getting. Now the moment you have considered x bar plus y bar, whatever the remaining combination you are having, that combination you can consider. Y plus x or x plus y, both are same. Okay, I am repeating once again. Like here, consider case by case. Like x bar plus x, when you have considered that you are getting 1, that combination you can avoid. Then x bar plus y bar. Okay, the moment you have considered x bar plus y bar, here whatever the remaining variables are there, that you can consider. So here if you do further simplification, x bar into x 0, x bar into y, that means first term, y bar into x second term, y bar into y 0. Now you can observe this is in sum terms product together, POS form. POS form. So this you are getting by using transposition law. By using transposition law. Okay, this is just nothing but if you observe from distributive law only, it is like special case we can consider. Like suppose here x bar y is there, the moment if y is not there, how you will perform? Same logic. X bar plus x is 1, so you will get x bar plus y bar, correct? Now ignore that one, y plus x into y plus y bar is 1, like that. Okay, in this way you can convert SOP to POS with the help of distributive law and with the help of transposition law. Other than these two, if you are getting any question, okay, that time what you have to do, from the given SOP you have to get back to sigma m, and from there you will get pi capital M, from there you can get POS. Or in other words, suppose if you are having choices, okay, suppose somehow that you got SOP, but unfortunately you are having choices in POS, you can verify option by option also. Okay, from whichever option you are getting your SOP, that will be the correct. Is it clear, Isaki and other students, how to do the conversion of SOP to POS and similarly POS into SOP? Yeah, I hope it is clear for everyone. So up to now we have discussed regarding first 2 chapters. Okay, we started with the number systems and codes. Regarding that we have discussed number system conversions and then basic arithmetic operations, like and how to find the base or radix, the important relation, and then we have discussed regarding number system representation, especially the sign numbers, right, data representation. So we are having unsigned numbers and then signed numbers, among which 1's complement form, 2's complement form and sign magnitude form. Regarding those numbers, range we have discussed, and then regarding 2's complement, whatever the important points are there, all those points we have covered, and then binary codes we have discussed, BCD code, XS3 code, gray code, how to do the conversion of binary to gray and gray code back into binary. And then second chapter we have discussed all the important laws of Boolean algebra. With the whenever you are supposed to do the simplification based on the requirement, first of all you take the common terms. After that, whichever law or rule required you can apply in order to get the simplified function. So with the help of Boolean algebra rules you can solve the question, and similarly with the help of K-maps also you can solve the question. Okay, so whenever the question is regarding prime implicants or essential or redundant, obviously you can solve that question by using K-map. But whenever the question is regarding simplification, So according to the given function, whichever method is comfortable, with the help of basic rules and laws of Boolean algebra or with the help of K-maps, you can go ahead. Okay, and then we have discussed all the important points with respect to Boolean functions and K-maps. So these are very, very important points. Okay, so after 15 minutes we are having the next session. So in that session we will discuss the remaining chapters of digital circuit subject. So all of you just take 15 minutes break and we'll meet you all sharp at 3:30 today. Okay, thank you everyone.